Good morning, students. Myself, Major Komal Katyal, Department of Zoology, GK Govani Government College, Bhinmar. In continuation on my lecture on blood circulatory system, today we will discuss about the cardiac cycle. Now, the cardiac cycle includes all events associated with one heartbeat, including diastole, that is the relaxation phase, and the systole, that is the contraction phase of both the atria and the ventricles. It means हृदय चक्र के दौरान जो हृदय के अंदर शीतलन व संकुचन की प्रक्रिया होती है, जो हृदय के चारों कक्ष हैं, दो आलिंद और दो निलय. In each cycle, atria and ventricles alternately contract and relax. During atrial systole, the ventricles are relaxed, and during ventricle systole, the atria are relaxed. Since ventricular function matters most to the body, the two principal events of the cycle for us to understand are ventricular filling, that is during ventricular diastole, and second the ventricular ejection, that is during the ventricular systole. कहने का मतलब ये है कि निलय में किस तरह से रुधिर भरता है और निलय से किस तरह से रुधिर बाहर धमनियों में प्रभावित होता है, पंप किया जाता है, वो हमारे लिए ज़्यादा महत्वपूर्ण होता है. जब निलय के अंदर रुधिर भरता है तो शीतलन की अवस्था होती है, और जब निलय द्वारा रक्त धमनियों के अंदर या महाधमनियों में प्रवाहित किया जाता है तब वो अपनी संकुचन अवस्था में होता है. The blood pressure that we measure in the arm is a reflection of the pressure developed by the left ventricle before and after the left ventricular systole. Pulmonary blood pressure is a result of right ventricular function, but it is not easily measured. Now, let us discuss about the sequence of the cardiac cycle. First of all, the atrial systole, followed by atrial diastole and the ventricular systole, and after that the ventricular diastole. All these events takes place only 0.8 second. It means in one heartbeat, the one cardiac cycle is completed in 0.8 second, which includes the atrial contraction. You can see in the figure, it is pumping the blood into the ventricle from right auricle to the right and from left auricle to left ventricle. Then the isovolumetric contraction, that is of ventricle. It is known as isovolumetric contraction because at the initial stage of contraction, the volume of both the ventricle remains same, and just after the isovolumetric contraction, the ventricular ejection takes place. It means blood from the left and the right ventricle is pumped into the aorta and pulmonary arteries. Then isovolumetric relaxation, that is relaxation of the ventricle, where the volume of the ventricle remains the same but it is in relaxed phase. Then during the diastole, the ventricular filling starts and again the atrial contraction begins. So these are all the phases of a cardiac cycle. Now let us compare the opening of different valves. On the right side we have mentioned regarding the atrium, and on the left regarding the ventricle. During the ventricular diastole, the atrioventricular wall is open but semilunar wall is closed. This is the condition during atrial systole also. Now during the ventricular systole, the AV walls, both means tricuspid and bicuspid wall, are closed while semilunar walls are open, but atrium is in the early diastole phase. Then the double diastole, that is the ventricular diastole as well as the late atrial diastole, the semilunar walls are closed but auriculoventricular wall means tricuspid and bicuspid walls are open. This is what we have just studied during the atrial systole, then the early ventricular systole, the late ventricular systole, and early ventricular diastole and late ventricular diastole. All these conditions we have already discussed in the previous slide. Now step by step, the first one is the atrial systole. So during the atrial systole, prior to the atrial systole, the blood has been flowing passively from the atrium into the ventricle through the open auriculoventricular wall, that is the tricuspid and the bicuspid wall. As you can see in the diagram also, the arrow is showing that from the left ventricle is receiving the blood from the left auricle, and while right auricle is sending the blood to the right ventricle. During the atrial systole, the atrium contracts and tops off the volume in the ventricle with only a small amount of blood. Atrium contraction is complete before the ventricle begins to contract. So this is the first phase. पहली अवस्था के दौरान क्या हो रहा है, आलिंद के अंदर संकुचन हो रहा है और उस संकुचन से पूर्व ही आलिंद से निलय के अंदर रुधिर जाता रहता है। जब उसमें संकुचन होता है तो तेजी से रुधिर आलिंद से कहाँ जाता है, निलय के अंदर जाता है। Then the isovolumetric contraction. This is the contraction of the ventricle. During isovolumetric contraction, as it is clear from the name, isovolumetric, it means the volume of the respective ventricle, that is the right and the left ventricle, remains the same. Second, during this contraction, the atrioventricular wall, that is the AV walls, they remain closed at the beginning of this phase. Second, electrically, the ventricular systole is defined as the interval between the QRS complex and at the end of the T wave, the QT interval, which we can see with the electrocardiogram, the ECG. Mechanically, the ventricular systole is defined as the interval between closing of the AV walls and the opening of the SL wall, that is the semilunar walls, aortic and pulmonary walls. Now the rapid ejection, the third phase. During rapid ejection, as you can see with the diagram also, the arrow is showing the left ventricle pumping the blood into aorta and the right ventricle is pumping the blood into pulmonary artery. The semilunar walls open at the beginning of this phase. And at the end of this phase, the semilunar wall closes. So first one is the rapid ejection and the second one is the reduced ejection. So there are two different phases. The initial one is the rapid ejection, during which quickly the blood is pumped into respective aorta and pulmonary artery, and during reduced ejection, small amount of blood moves to the respective aorta and pulmonary artery. But at the end of this phase, both the wall, that is a SL wall, closes. Now the isovolumetric relaxation. It means the volume of the ventricle at the initial stage remains the same, but ventricles are in the relaxed phase. कहने का मतलब ये है कि निलय का आयतन समान रहता है, वो शीतलन वाली अवस्था के अंदर है. So at the beginning of this phase, the AV walls remains closed. Now the rapid ventricular filling. Still the ventricles are in the relaxed phase and the atria are also in the relaxed phase. Small amount of blood is entering and then the rapid ventricular filling starts when the atrial systole begins. Once the AV walls opens, the blood that has accumulated in the atria flows rapidly into the ventricle. जैसे ही आलिंद के अंदर संकुचन होता है, बहुत तेजी से रुधिर दाएं और बाएं आलिंद से बाएं नीले में और दाएं आलिंद से दाएं नीले के अंदर जाता है. And after some time the reduced ventricular filling, it means the amount of blood which is entering the respective ventricle become slow down. So after this the AV valves closes. This is the conduction system of the contraction of the heartbeat. You can see the SA node, that is a sino-auricular node, which is also known as the pacemaker, present in the wall of the right auricle, and it transmits the impulses through internodal tracts to AV node, that is auriculoventricular node, and from auricular ventricle node via bundle of his they goes to the walls of the respective ventricle, that is the right and the left ventricle, right bundle branch and the left bundle branch, the Purkinje fibers. This is what I have just explained, that how the conduction is taking place. Now during the cardiac cycle, all of the 4 heart valves have a chance to open and close, and we can listen the same with the help of a stethoscope, and the sound of lub dub is associated with the heart sound. The average time required to complete the cardiac cycle, as I told you initially, it is 0.8 seconds at the heart rate of 75 beats per minute, with 0.1 second for atrial systole, 0.3 second for ventricular systole, 0.4 second for double diastole. The cardiac output, the CO. The stroke volume is the volume of blood ejected from the left or right ventricle every beat, and the cardiac output is the stroke volume multiplied by the heart rate. कहने का मतलब ये है, स्ट्रोक वॉल्यूम मतलब एक स्ट्रोक में, एक हार्ट बीट में कितना रुधिर हार्ट ने या हृदय ने पंप किया है, वो कहलाता है स्ट्रोक वॉल्यूम, which is normally 70 ml per beat. And if in a human being heart beats 75 times per minute, approximately 5.25 liter of blood is pumped to the body organs. So on average we can say a person's entire blood volume flows through the pulmonary and systemic circuit each minute. Now the cardiac reserve. It is a difference between the cardiac output at rest and the maximum cardiac output the heart can generate. Average cardiac reserve is 4 to 5 times the resting value. Exercises draws upon the cardiac reserve to meet the body's increased physiological demands and maintains the stage of homeostasis. Now the cardiac output is affected by changes in the stroke volume, by the heart rate, or by both. There are 3 important factors that affect the stroke volume. 1. The amount of ventricular filling before the contraction, that is called the preload. Then the contractibility of the ventricle. Third, the resistance of the blood vessels, that is aorta and the walls of the aortic and when damaged. And the heart is pumping into the blood, that is the afterload. So preload, the contraction phase, and afterload, all these affect the cardiac output. You can see here, the more the heart muscle is stretched, filled before contraction, that is the preload, the more forcefully the heart will contract, and this phenomenon is known as the Starling's law of the heart. Now, how the sports person generate, you can see with this figure that there is increased preload affecting the nervous system. The cardiovascular system in the medulla oblongata receives input from the cerebral cortex, the limbic system. Then the increased contractibility increase in the stroke volume, and there is increase in the rate of heartbeat. The other factors which are also responsible for increasing the cardiac output. So this is all about the cardiac cycle. With this, I finishes my lecture. Thank you.